This video is about chapter 3.2, which are properties of parallel lines. So in chapter 3.1, we were noticing that if we had two lines that were cut by a transversal, then we created certain angle relationships. Like for example, okay, don't know why that keeps doing that. For example, angle 1 and angle 3 would be corresponding angles. Angle 3 with angle 5 would be alternate interior angles, and so on. Well, something interesting happens when these lines that are cut by the transversal all of a sudden become parallel. So those relationships based on location are still the same. And notice that I've made those lines parallel. I've indicated that they are with those arrows that match from one arrow on the other. And so that's telling us that those lines are parallel to each other. So when those lines that are cut by the transversal are parallel, not only do we have those locations, but we have certain relationships. So corresponding angles, for example, angle 1 and angle 3, when parallel lines are cut by a transversal, then corresponding angles are congruent. And you need to say that whole thing, or you can say the corresponding angles postulate. I would accept the word theorem, something that indicates that this is a stated fact. You can't just say corresponding angles, because we know that when those lines are not parallel, you still can have corresponding angles, but the angles that are created are not congruent to each other. So the key is that we have parallel lines that are cut by a transversal, and when we do, the corresponding angles theorem would say that the corresponding angles are congruent. Alternate interior angles theorem. So again, those are angles like 3 and 5. Those are alternate interior angles. When parallel lines are cut by a transversal, then alternate interior angles are congruent. All right, same side interior angles. So that would be like angle 5 and angle 4. They are on the same side of the transversal, and they are inside those two parallel lines. They're the only ones that have a different relationship. When parallel lines are cut by a transversal, same side interior angles are supplementary. And sometimes you'll hear me in class say it in a very exaggerated way, same side supplementary, all those S's to help us remember that that is sort of the different example. And then finally, alternate exterior angles. That would be like angle 1 and angle 7, for example. They are on opposite sides of the transversal. They are both outside of the parallel lines. So when parallel lines are cut by a transversal, then alternate exterior angles are again congruent. So all of them are congruent when the lines are parallel, except for same side interior angles. All right, so what's great about this is now if we have two parallel lines, so again, remember, these are my parallel lines, and my transversal is the one that cuts them or connects them. Okay, so I'm going to be turning my head a little bit sideways when I look at this, and I see that angle 5 is 55 because I've been given that, and I'm asked to basically fill in all of the rest of them. And what's great is now when the lines are parallel, you actually can. So first of all, we can fill them in here pretty easily with some of the relationships we knew from the last chapter. For example, I know that angle 1 is 55 degrees because these are vertical angles, and vertical angles are congruent by the vertical angles theorem. I know that these two angles form a linear pair, and so therefore they add up to 180. So I know that angle 2 is 125 degrees, and once I know that, vertical angles theorem tells me that angle 4 is also going to be 125 degrees. So those four in this one section that share a vertex are going to be solved for the way that we did really early in chapter 2. But now we have this great feature that because we have parallel lines that have been cut by a transversal, these angles here on the left are able to now be related to these angles here on the right. Okay, so for example, angle 4 and angle 8 are corresponding angles. So corresponding angles theorem says that they will be congruent when parallel lines are cut by a transversal, so I know that angle 8 is 125. Now I could fill in the rest using linear pairs or vertical angles, or I could still relate them back to the other ones. So for example, angle 6 and angle 4 are alternate exterior angles. Alternate exterior angles are congruent when parallel lines are cut by a transversal, so angle 6 is also 125. I can see that angle 5 and angle 2 are same side interior angles, which means they must be supplementary. So angle 5 is 55. When lines are parallel, that will be true. Okay, so there's lots of ways we can do that. I could use vertical angles theorem and now know that this is 55. So you might have done it in a different way, but the key is that we are recognizing that these relationships hold true when the lines are parallel that are cut by the transversal. Okay, now here I have two different sets of parallel lines, so I'm going to be working on filling in. I only know one of the angles, which is 105. I know that angle 7 is also going to be 105 by the vertical angles theorem. So first I'm going to look at these two parallel lines and use this transversal. So if I'm using that transversal, the only angles that I can be relating are these angles here. So those are the two sets of angles that are connected by that and created by that transversal, so they are the ones that can be related to each other. Well, I can see that angle 5 and this 105 are corresponding angles. Because these two green lines are parallel, corresponding angles are congruent, so I know that angle 5 is 105 degrees. I now could do angle 3 by vertical angles theorem. I could see that it's 105. Or I could do corresponding angles between angle 3 and angle 7. Corresponding angles theorem tells me that they will be congruent when parallel lines are cut by a transversal. Now using these two parallel lines and that transversal, those are the only relationships that I can create. I could go over and look at this transversal, but then I'd be looking at these angles here, but I don't know any of their measures. So that's not going to be the best way for me to proceed. So instead, I'm going to now use the fact that we actually have two other parallel lines. These have a single arrow, these have a single arrow, so those are connected to each other. And I can now use this transversal, for example, to connect these angles on the left with these angles on the right. I can see that angle 6 and angle 7 are corresponding angles. Corresponding angles theorem tells me that when the lines are parallel that are cut by the transversal, then they are congruent, so angle 6 is 105. I can see that angle 4 and this 105 angle are same side interior angles, and we know that when those lines are parallel, then they are going to be supplementary, so angle 4 is going to be equal to 75. Which, by the way, we also could have said, oh, it's supplementary to angle 6. So again, there are a couple ways to do these things. There's not just one, but whatever you see first, hopefully as long as it's a correct geometric relationship, that's fine. And now finally, if I need to get to these angles 1, 2, and 8, I need some transversal that's going to connect it to another set that I know. Well, here's a transversal that connects it to angles 3 and 5. So I can see that angle 2 and angle 5 are same side interior angles. That means that they are supplementary when the lines are parallel, so angle 2 is 75. Vertical angles theorem could tell me that angle 1 is also 75. I could say that these two angles are supplementary, so therefore angle 8 is 105. Or I could have said that angle 8 and angle 3 are corresponding angles, and because the lines are parallel, they are congruent. So those are all different ways I could do these processes to fill these in. All right, so number 3, has a couple of extra things going on. And so when I see lots of different lines, sometimes it's really helpful to just clarify what I'm looking at. These are my parallel lines. Now I have two choices of transversals because this line cuts through them and this line cuts through them. So now I'm trying to find out which one of these are going to be helpful for me. Well, if I use the green line, then I would be relating these angles down here to these angles. But down here on the right, I don't have any angle measures. So that's not going to be a helpful transversal for me to use. So I'm going to go back to this yellow angle. Now I have this angle is 80 degrees. And I can't just use Y. I need to go all the way from the transversal all the way to the other parallel line. So these two angles here, this whole angle and this 80-degree angle, are same side interior angles. And we know that when lines are parallel, same side interior angles are supplementary. So one of my angles is Y plus 40. That plus the 80 has to add up to 180. They are supplementary. So this is Y plus 40 equals 100. So Y equals 60. The key is to make sure that because I'm using these highlighted lines, I have to use this whole angle. to be same side interior with this whole angle. Okay, again, noticing the parallel lines and the transversals. These are my lines that are parallel. I'm going to pick one of the transversals. I see two different ones, so let me use this transversal. So if I'm using this transversal, I'm connecting the angles up here with the angles down here. And I can see what relationship does 2x and x minus 12 have? Well, they are both interior angles, meaning they're inside the parallel lines, and they are on the same side of the transversal. So that means they are same side interior angles. We know that when lines are parallel, same side interior angles are supplementary, which means they add up to 180. So this is 3x equals 192, so x equals 64. All right, now I want to solve for y. I still only have one set of parallel lines, so those are going to stay the same, but now I'm going to try the other transversal because that will connect these angles to these angles. Again, 3y and y plus 20 are inside the parallel lines. They are on the same side of the transversal, which makes them same side interior angles. And we know when lines are parallel, they are supplementary. So this is 4y plus 20 equals 180. 4y equals 160. So y equals 40. Okay, and again, really identifying which are the parallel lines and transversals that are going to be useful for you.